Well, hi there, kids. It's time for Unit 9 Basics. Last one before the practice test. After this, we only have 2 more units left. Tangent and statistics. Oh my God, it's so exciting. So anyway, let's get started. Let's get rolling. So what we're going to talk about is applied forces. I'm not sure if we're going to do it the same way you do it in physics exactly, but you know me, when I talk about applied forces, I gotta have some Dunkin' Donuts coffee. Oh, it's so delicious. Hot! Holy crap! All right, that was really hot. I don't know if I've ever had it that hot before. Woo! Anyway, let's get back. So let's say I have a body, a thing right here. And I'm going to apply a force going this way. I know you think you got to apply a force behind it, but when you take physics, you'll understand that the force and the magnitude of the force is off into this direction. And then let's say some other idiot, I'm trying to push it this way, and then, some other annoying child, I'm not going to say who, I'm sure you know who you are, is trying to push it in this direction. Well, if I'm pushing it this way, and they're pushing it this way, then what happens is it doesn't really go in either of those directions. It's sort of in the middle. It sort of goes in that direction. Now, the reason it's going a little bit more to the right than it is going up is because I'm quite a bit stronger than that annoying person in class, the one we're talking about. So since this force, call this force 1, is larger than force 2, it's really going to go off a little bit into this direction. Now, what we're going to do is with these diagrams, what we're going to do is we're going to make a parallelogram. So although we're going to have forces, we're really going to deal with a parallelogram. And therefore, in dealing with a parallelogram, what I'm really dealing with is 2 triangles, 2 congruent triangles. Really, I'm dealing with 2 congruent triangles. Let's talk about some geometry facts, some things you might have to remember from geometry or from algebra whenever you learned it. Have you ever heard of these things called alternate interior angles? Alternate interior angles are congruent. Like, for example, if I have angle 1 here, it's congruent to angle 2. So angle 1 is congruent to angle 2. And then angle 3 is congruent to angle 4. I should just call it 4. Or angle 3 is congruent to angle 4. Those are things you know. Here's a big one. This is going to be huge, huge, huge. 2 consecutive angles in a regular, now I'm going to say regular quadrilateral because it's true for any regular quadrilateral. In this case, we're going to be dealing with parallelograms, but this is true for any quadrilateral, are, my head's in the way, supplementary. I'm afraid to take another drink of coffee. Supplementary. Another way to say it is they add up to 180 degrees. So, if I told you that this angle here, this yellow angle, was 120 degrees, then you would tell me that this angle here would be 60 degrees. They have to add up. That one's going to become really important. And then we're also, just so you know, we're going to use the law of cosines. Law of sines and the law of cosines when we're doing these. Okay, so let's see how it works. This stuff's not very difficult, but it is kind of difficult. I couldn't get rid of that. So 2 forces of 12 pounds and 20 pounds. Now, I really want to make sure you understand. I want you to draw one so it is so, I don't care if it's 1 pound more. I want you to make sure it's so far longer than the other one. and then draw another one at an angle. So there's my 12-pound force, and there's my 20-pound force. Now don't do anything until you have finished drawing your parallelogram. Damn, I don't know why that's so hot. Darn, I don't know why that's so hot. So let me grab a different color. I'm going to grab orange. And I'm going to finish drawing my parallelogram. Now you got to be careful and you got to be able to read properly. Two forces of 20 pounds and 12 pounds act on a body with an angle of 60 degrees between them. So this is 60. Now I'm going to use that thing I starred earlier to realize that this is, and I didn't mean for it to be that easy, 120. Because they have to add up to 180. Find to the nearest pound the magnitude. The magnitude will always be this diagonal value. So we're going to be looking for x. So let's see what we got. I have no idea what we got. Oh, I have no idea what we got. We got that that's 120. I got this is 12, right? That was 12. This is 20. Anything else I got? I got this is 120. This is 120. I'm just going to forewarn you, and I want you to really, really, really just mark this. The resultant I'm going to say never, but I don't really mean exactly never, but almost never bisects this angle. I get so many kids like, well, that's 30, then that's 30. No, it's not 30. I have no idea what it is. It could be 22.48. I have no idea what it is. So now I got a result. Now I got to go back and I got to go, okay, let me go back to my law of cosines document. My law of cosines document somewhere had a flow chart for me. And I got to decide whether or not I want to use law of sines or law of cosines. Now, ultimately, I want to find a side. I want to find a side. So I want to find a side or find a side. So I got to decide, do I have two angles? If I have two angles, I'm going to use the law of sines. If I have two sides, I'm going to use the law of cosines. So let's go back to see what we got. I've got a side here. I've got a side here, and I've got a side here, and I've got an angle. So what I have is side, angle, side. And because I have side, angle, side, I'm going to be using the law of cosines. Now, if you remember correctly, the law of cosines is this. Little a squared is equal to little b squared plus little c squared minus 2 times little b times little c times the cosine of a. There is nothing magic about a and a. All that means is they are opposite from each other. So, oops. I'm trying to get rid of this, but it's not letting me. All right. So what is opposite of, I want to find x. So what is the angle opposite x? It's 120. So those are going to be my a's, if you want. Or in this case, because I'm using x, I'm going to call this x and this x. Regardless, here we go. X squared is equal to b squared. It doesn't matter now what you call the other ones. 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 120. Now, I'm just going to remind you, these are all numbers. And because they're all numbers, you got to be, yes! It's when you have to find an angle that it's a pain in the keister. So since they're all angles, all I got to do is type that stuff in. I'm going to type that into my calculator. So I'll take out the calculator, and I'll go 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine, make sure you're using cosine, of 120. And I get Wow, exactly 784. That's really doesn't happen very often. 784. Be careful, be careful, be careful. That's not our answer. We still have to take the square root. And if you take the square root of 784, and again, it's not x squared, it's just x. I'm just going to go raise it to the 0.5 power because half is a square root and hit enter. 28. So x equals 28. There we go. Done. Let's try the next problem. Two forces of 30 and 40 pounds act with an angle of 120 between them. Now, see how this is 120? Maybe I want to try to make it a little bit more seemingly like a 120. So let's do this. Remember, one's going to be a lot longer, so we'll make one long and one short. But notice I made it about 120 degrees. Why am I using 120 again? That's weird. So now what I want to do is I want to finish my parallelogram. Find the magnitude of the resultant. We're looking for a resultant again. So let's draw in that resultant. Let's do cool blue. The resultant then would be into this direction. So this is 30. This is 40. This is 30. This has to be 60 then, right? It's a terrible drawing, but this is 120, so that's 60. And I'm looking for the resultant again. Wow, this is easy. So I'm going to do x squared equals 30 squared plus 40 squared minus 2 times 30 times 40 times the cosine of 60. This is going to be a nice number again, too. Maybe not. So 30 squared plus 40 squared minus 2 times 30 times 40 times the, make sure you're using cosine, don't be falling into sine trap, 60. And I get 1300. So x squared equals 1300. And then I'll come through and I'll take the square root. Remember, the easiest way to take the square root is just to hit raised to the 0.5. And I get 36.055. So x is equal to 36.055. Rounded to the nearest pound. X is equal to 36 pounds. 8. Oh, it's 20 and 40. I used 30 and 40. Oh, no, what's 30 and 40? Oh, it is 30 and 40. Oh, okay. All right, never mind. Okay, next problem. We don't have many more. These aren't that difficult, but once we have to go find angles, then it becomes a lot more difficult, a little bit crazier. Two forces act on a body so that the resultant force is 50 pounds. Okay, so as soon as I hear that, I'm going to draw one long side, one short side. Now you're going to see why in a second I do this, I believe. Finish filling out that parallelogram, and then I'll draw in the resultant. The resultant is diagonal from here to here. Now, the measure of the resultant is 50 pounds. So that's 50. The measures of the angles between, now be careful, you have to be able to read, between the resultant and the forces. So here's the resultant. So the measure of the angles between the resultant, that's this angle, and the forces, and this angle are 25 and 38. Now where do you think you're going to put the 25? On the smaller one, obviously. And then 38 on the larger one. It just makes more sense. And that's one of the reasons why you want to have one longer than the other. Well, if that's 38, then this is 38, because they're alternate interior angles. Now, 25 and 38, I'm just going to find all the angles. It usually helps me out. Find all the angles. Let's see, 25 and 30. I'm just going to take 180, subtract off 25, subtract off 38, and I think it's 112, 117. 117. So 117. Now I have all the angles. So now I think I can answer some questions. Find to the nearest pound the magnitude of the larger applied force. Now, if you've drawn your drawing right, then you should say, oh, hey, this is the larger of the two forces. Well, I want to find x. Now, let's see what I have here. I have angles. I got all kinds of angles and only one side. And if you go back here, which one uses two angles and a side? Law of sines, exactly. So when I come back here, I know I'm going to do the law of sines. X over sine of 38 is equal to 50 over the sine of 117. Cross multiply, I get x times the sine of 117 is equal to 50 times the sine of 38. Divide by the sine of 117 and type that into my calculator. So 50, not 55, 50 times the sine of 38. Oh, control division. All divided by the sine of 117. And I get 34.54. X equals 34.54. And I think it was 86, something like that. And I want to round it to the nearest pound. So my answer is X equals 35 pounds. Bodied. All right, kids, two left. When force of 12 and 8 pounds act on a body. As soon as I hear that, one long one, one little one. Grab my next pen and finish that. I've got 8 pounds and 12 pounds. And the resultant is 50. They actually told us the resultant is 15. Now let's see what else I know. I know this is 8 and I know this is 12. Find to the nearest degree, the measure of the angle between the resultant and the larger force. So I want to know the angle between the resultant and the larger force. So I'm actually looking for this angle, x. But do you notice you don't have any angles? And if you don't have any angles, but you do have 3 sides, side, 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 we're going to use the law of cosines. And we're finding an angle. So come back, think. Let me highlight. I'm looking for this angle. And this is the side that's opposite. So when I go to write my formula, a squared is equal to b squared plus c squared minus 2bc cosine a. These two things are the highlighted things here as well. Okay? So let's see what we got. In for a is going to go 8 squared. Now I'm going to copy the other stuff down. 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of a. Oh, shoot. This is that hard case where I have to find the angle. Oh. Remember, you want to do this in pieces. You're going to do this piece, and you're going to do this piece. Don't put them together. They do not get put together. This is multiplication. This is subtraction. You can't put them together. So let's go through this. This is 64 is equal to, let's see, 144 and 2, whatever. Come over here. My brain's too tired. I just got done working out. 12 squared, why did I multiply? Plus 15 squared is equal to 369. Minus, let's see, 180, 360. But let me just check. I think it's 360, but let me just make sure. My brain's a little tired. 2 times 12 times 15. It should be 360. Minus 360. Minus 360 times the cosine of A. Again, do not put these together. This needs to come over. So 64 minus this is equal to negative 308. So I end up with negative 308 equals negative 360 times the cosine of A. Now we're going to divide by negative 360. Well, the two negatives make a positive. So I end up with cosine, let me get a new pen here. I end up with cosine of A is equal to 308 over 360. Now I'm going to bring that cosine over here, make it inverse cosine. I don't like to type anything in my calculator until I'm ready. Type that in there, and I get A equals, so inverse cosine of 308 divided by 360. Inverse cosine 308 divided by 360. Enter. 311783. What the heck? 31.1783. And I think it said round to the nearest degree. Round to the nearest degree. The answer is 31 degrees. There it is, kids. Well, that's interesting. That's not what I got here. Oh, it's got to be. I'm right. And my notes are wrong. So there it is. All right. Find to the nearest degree the measure between two applied forces. Draw my picture. One long one. And one shorter one. Grab a different color. Finish them in. Grab a different color, because more colors is more fun. That is a horrible line. Let's try to see if I can make that a little bit better. It's a little bit better. All right, so the two applied forces are 9 and 11. And the resultant is 14. So 14, 9, and again, I'm in the side situation. So this is guaranteed I'm going to be using law of cosines. Now, what do I want to find? Find to the nearest degree the measure of the angle between these two. So I want to find this one. I need to find the angle between the two forces. Let me just tell you this. You can't find this. It's not possible. Oh, wait, hold on. Directly. You can't find it directly. You have to find it indirectly, which means I'm not really finding this. What I really want to find is this. You know, if I told you this was 100 degrees, and you'd say, oh, then this angle here must be 80, because they have to add up to 1. But I don't know what this one is. So this is my goal. My goal is to find this one. We're going to call this x, and we'll call this x. All right, so we're going to use our formula. And our formula is a squared equals b squared minus plus c squared minus 2 times b times c times the cosine of a. So A, or x, or whatever you call it, are the two things that are opposite of each other. Those two things are opposite, so those two things go opposite in the equation. So 14 squared is equal to 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of, well, we'll call it x now, I guess. Now, just going to remind you, we're looking for an angle. This gets done independently of this. Don't do it together. Let's see, that's 196 is equal to 81 and 121. What's that, 202? Minus 99. Oh man, I'm doing all this in my head. I'm going to mess it all up. I don't even remember what it was. 81 plus 121. That's 81 plus 121. That should be 202. And then 18 times 11. 18 times 11. I'm just trying to make things a little bit easier. 198. 198 times the cosine of x. Subtract 202. 196 minus 2. This is how tired I am. I can't even find out a 6. Negative 6. See, I would have messed up. Negative 6 is equal to negative 198 cosine x. Divide by negative 198. Divide by negative 198. Now you'll notice those are positive. Something's not right here. Let's see how it turns out. So we're going to do cosine of x is equal to 6 over 198. That just doesn't seem like it's going to work out right. I don't know why. She swallowed the fly. We're going to do inverse cosine of that, right? Of 6 divided by 198. I hope this turns out to be a normal angle. Oh, 88 degrees. Did I not write this down right? Oh, man, once again, I wrote down the wrong numbers in my own problem. That's weird. It's 14 pounds. I wrote 17 pounds. I don't know. So x is equal to, I've got, what did we end up with? 88 point what? 88.26 degrees. 88.26 degrees. Rounded to the nearest degree, that's x equals 88 degrees. Well, if those are 88 degrees, this is 88 degrees, then this should be 180 minus 88, otherwise known as 92 degrees. So that should be the answer. The way to determine that. I want to triple check my answer. So what I'm going to do is, I said this was 88. So now I'm going to use side, angle, side to see if I come up with 14. So I'm going to go a squared is equal to 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 88. Now this should be close to 196. So 9 squared plus 11 squared minus 2 times 9 times 11 times the cosine of 88 degrees. Not going to be exactly 196, but it's really close. Okay, so we're good. That's the answer. 92 degrees. Yay! Done. Okay, kids, that's it. Day 6 over. Day 6 is a short day. I'm going to give you this, and I'll probably give you time in class to do the homework, maybe. And then I'll give you the practice test as well. Practice test will be my next video that you will see. All right, children. It's been fun, and it's been real. And it's been real fun. Oh, my God. Bye.